The ends of the string are kept fixed. A standing wave is established on the string. Explain how it creates a sound wave. Well, this thing is going to vibrate back and forth. It's going to strike the air, right? And that's going to create pressure. And talk about what kind of wave. What kind of wave is a sound wave? Is it transverse or longitudinal, right? And then just talk about the mechanism by which it can create the sound, right? And then part two here. The speed of sound in the air is 340 meters per second. The length of the string is 0.8 meters. And the speed of the wave on the string is 240 meters per second, right? So we want to figure out the wavelength of the sound in the air. And so to do that, ultimately, we're going to use V is F lambda, right? And we're going to do for air, right? Ultimately is that, right? Okay, but now we need to figure out what is the frequency, right, of this string, right? So we got to figure out this frequency, okay? Okay. So to figure out the frequency that the string vibrates at, you're going to set up a number sentence here, right? That length, which is 0.8 meters, right, is going to be so many quarter wavelengths, right? So that times the wavelength over 4, right? How many quarter wavelengths do you see here, right? So it's going to be that many quarter wavelengths, set it up, right? And then solve for lambda, right? Lambda is equal to, right, of this string, right? So is that the whole wavelength? Is a football a whole wavelength, or is it one or maybe half a wavelength, right? Okay, so figure out the wavelength, and then you're going to do V is F lambda for the string, right? And in this case, the velocity is 240 equals frequency times that thing you figure out, right? So maybe you do this first, right? Set up your number sentence for your standing wave. Okay, figure out that wavelength. Then solve for this frequency. Once you get that frequency, that's going to go there. And then do for the air, right? Set this thing up and solve for the wavelength in the air.